Picture this. You've got a crucial video conference happening between delegates in the USA and Mauritius. But suddenly, the video freezes, the audio completely drops out, and everyone's just staring at pixelated screens. Now, if you're sitting in your Cambridge IGCSE computer science exam and you're asked to describe exactly why this happens and how to fix it, well, you are staring right into a massive trap.
Listen to the student's answer. The video call glitches because the internet is slow and the connection drops between delegates. I mean, that sounds totally logical, right? It's exactly how we talk about tech problems in the real world. But if you actually write this in your Paper 1 exam, the examiner is going to do something pretty painful.
They're going to give this perfectly realistic sounding answer exactly 0 marks. Yep, nothing. Nada. You see, ordinary revision completely fails here because it's missing the highly specific technical mark magnets that examiners are actively hunting for. So in this explainer, we're going to expose exactly what those mark magnets are, and we're going to turn that 0 into a flawless 6-mark answer.
Section 1. The hidden chaos inside a data packet.
Okay, let's dive right into this. To get those marks, we literally can't just complain about slow internet. We have to look at the hidden chaos happening under the surface. This is the precise, Cambridge-safe definition of packet switching. Notice the specific phrasing here. Video and audio data is split up into data packets before it's sent over the internet. You absolutely must state explicitly that the data is broken down into these small, manageable chunks.
Now, what's really interesting about this is the structure of the packets themselves. Every single packet has a packet header, and honestly, this header is basically packed with crucial exam evidence. First up, it contains the IP addresses, which identify both the sending and receiving stations. Then, it's got a sequence number, so that when all these packets arrive, they can be correctly reassembled. And finally, it contains the packet size, which is just there to ensure the receiving station knows that the whole packet has arrived completely intact.
Section 2. The role of IP addresses directing the data.
Let's pull on that thread for a second, because if those addresses aren't perfectly managed, our USA to Mauritius video call is completely doomed. Comparing the two main types, we've got dynamic IP addresses, which actually change every time a device connects. This is great for privacy. But, and here is the absolutely crucial exam point, dynamic IPs are way less reliable for Voice over Internet Protocol, or VoIP, calls. They can just disconnect and change mid-session, which causes the connection to flat-out fail. On the flip side, static IP addresses are permanently assigned. They're fully traceable and faster, though yeah, they are more expensive to maintain.
And the protocol handling these addresses? It's currently upgrading from the older 32-bit IPv4 to the absolutely massive 128-bit IPv6. Just to put that into perspective, IPv6 has enough unique addresses to assign one to every single atom on the surface of the Earth. Literally. Upgrading to IPv6 entirely removes the risk of IP address collisions, it includes built-in authentication checks, and ultimately, it just allows for significantly more efficient packet switching.
Section 3. The packet switching journey. From the USA to Mauritius.
And this brilliantly illustrates the chaotic journey of these packets across the globe. Visually tracking this gives us the exact sequence you need to memorize for your exam. Step 1. The data gets split into data packets. Step 2. Each packet travels a completely different, totally unpredictable route from delegate to delegate. Step 3. Because they're taking all these random routes, they take different amounts of time. Some show up early, some are late, and some might even get completely lost along the way. Finally, Step 4. Upon arrival, they require reassembly into the correct sequence, all based on that handy little sequence number in the header. Which naturally brings us to the ultimate question. What actually happens when packets get lost or when reassembly into the correct sequence causes a time delay? Well, this is where we close the loop. This underlying technical chaos, the lost packets, the delays in reassembly, this is the actual scientific reason behind our glitchy video call.
Section 4. Pause and solve. Can you spot the missing tech terms?
Okay, I'm going to challenge you here. Based on the mechanical steps we literally just walked through, try to mentally predict the actual network theory that causes the glitch. And remember, do not use the words slow internet. To upgrade our original 0-mark answer to a flawless 6 marks, we have to use what I like to call scenario nouns. See, the examiner doesn't just want some abstract theory. They want that theory applied directly to the video call between the USA and Mauritius. Connecting the abstract concepts, like packet headers and routing, to the specific scenario nouns, that is your ultimate exam hack.
Section 5. The mark magnet answer. Examiner approved. All right, let's bring out the metaphorical red pen and deliver the exact framework you need to completely ace this question. Listen to this genuine top-band mark magnet answer carefully. Video and audio data is split into packets. Each data packet could potentially follow a different route. Packets could take different times, or some may even become lost. The arriving packets need to be reassembled into the correct sequence, which causes a time delay. This leads to freezing images, dropouts, or voice out of sync. Notice how beautifully technical terms like reassembly and lost packets translate perfectly into the physical symptoms of freezing images and out-of-sync audio. Honestly, that is a masterclass in scoring 6 out of 6.
Now, to consistently pull marks like this across the board, you have to master the essential command words. When an exam says describe, you state the points or features. If they say calculate, you work it out from the given facts. Compare means identifying similarities and differences, and evaluate requires a judgment of quality or importance. Knowing exactly what the examiner is asking for is literally half the battle. Oh, and by the way, be sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE, so you can keep excelling in your Cambridge examinations.
So here's the crucial takeaway. You've just secured maximum marks in Paper 1 for data transmission. You know exactly how to hack the marking scheme for packet switching. But there is a massive cliff edge waiting for you in Paper 2. How do you lock down those top bands when the examiner asks you to evaluate complex algorithms? Well, that requires a completely different mark magnet framework, and we are diving into that exact evaluation strategy in our next explainer. You absolutely do not want to miss it. Let's keep this momentum going.